Okay, question 5. We have a series circuit set up here, and the first part wants you to identify this component Y. That is a diode, and you need to know those circuit symbols. Part 2 tells you that the ammeter reading here is 0.02 amps. This is a series circuit, and so the current should be the same everywhere, which means that these current readings will be the same as that one, and so the answer is C. Part C, work out the voltage across this component here, which is a variable resistor. You should know that in series, the drops in voltage across each of the components needs to add up to the voltage that you supply. And so we put 9 volts in here from our battery. We have 2.37 and 0.71 volts being lost or dropped here. And therefore, we need to work out the leftover volts across this one, which needs to then add up to 9 volts when we add up these three together. And so we do a simple subtraction, and we find that the answer is 5.92 volts. Lots of you got 5.92, but so many of you forgot to put the units. And to get the 2 marks, you needed to have the unit there as well. Part D, again, something that caused a few problems, mostly because you didn't pay attention to this word here. It says explain, not describe. So explain requires you to say why the curve or the data looks as it is. You need to explain what's going on inside the metal filament to explain why this has got this shape. So we've got 4 points here which you should have a look through. But the basic gist is that as the voltage is increased, the current goes up. But what that does is it heats up the filament. It makes the ions inside the filament vibrate with a greater amplitude, which means that the electrons essentially get scattered more. Effectively, what happens is the resistance of the filament increases, and so the curve or the graph starts to curve because the temperature has risen, the resistance has gone up, and so forth. Therefore, the current can't increase as quickly or as much as it was previously. Question 6. We've got a speed time graph here. A child running out in front of a car. Not a very cheerful question. What is the driver's reaction time in milliseconds? The answer is C. See if you can work out how to do that. But essentially what you need to do is have a look at its speed and the time the time here on the x-axis that the person will start to brake, and the speed will start to go down. So they start to decelerate here, and that happens at 0.8 seconds on the x-axis, which is the same as 800 milliseconds. So you had to do a little conversion there. How long does it take for the brakes to stop the car? You have to take this time here from when it starts to slow down to when it stops, which if you look carefully, you can't quite see it on here, but it's about 3.2 seconds. So D. Part C, what you needed to do, you should know that the area under a speed time graph gives you the distance traveled. So what we've done here is we've split up this shape into a rectangle, which is, if you draw using a ruler, we'll look very carefully, it's about 0.8 wide and 15 high. You need to make sure you read the scale on here properly. Each little square is 0.4 meters per second. So you've got a rectangle, and then you'll have a 3.2 wide triangle, which is 15 high, which you can then work the area out using a half base times height. If you add those two together, you get 36 meters. Big 4 marks there, or you could have used the trapezium rule. Part D, someone's now been drinking alcohol and the road is wet. Draw a new line or a new speed time graph. Well, obviously, this line will come out further. This is essentially the reaction time, isn't it? And so it will take longer for that person who's under the influence of alcohol to recognize the danger and put the brakes on. So the reaction time has increased. And also the deceleration or the rate at which it slows down will be slower, and that's indicated by a shallower gradient. I took a mark off if the gradient of this line, this decline here, was not shallow enough. I wanted a very obvious difference between the gradients of these two lines, and so I was quite harsh in taking a mark off if it wasn't shallow enough.